Welcome. Today we'll prove that the derivative of cosecant of x is equal to negative cosecant of x times cotangent of x. Let's start by recalling that cosecant of x is equal to 1 over sine of x. Therefore, we'll need to use the chain rule since we're dealing with a composite function. For our case, we're dealing with the derivative of 1 over sine of x. Let's rewrite this using the power rule for derivatives. 1 over sine of x can be written as sine of x to the negative first power. Using the chain rule and power rule together, we get negative 1 times sine of x to the negative second power times the derivative of sine of x. We know that the derivative of sine of x is cosine of x, so let's substitute that in. Now, let's rewrite this in terms of cosecant and cotangent. Remember that cosecant squared is 1 over sine squared, and cotangent is cosine over sine. Using these identities, negative 1 times 1 over sine squared times cosine can be rewritten as negative cosecant squared times cosine over sine. And finally, we recognize that cosine over sine is cotangent of x, giving us our final result. The derivative of cosecant of x equals negative cosecant of x times cotangent of x. Let's visualize why this makes sense geometrically. Here's our unit circle. For any angle x, cosecant is the length from the origin to where the secant line intersects the unit circle divided by the height of that point. As x changes, this length changes at a rate proportional to both the cosecant and cotangent of the angle, and that completes our proof of the derivative of cosecant of x. Remember the key steps. We use the chain rule, power rule, and trig identities to convert our expression into its final form. Thank you for watching.